Hi, and welcome to the second part of the Evoca webinar series on disinfection solutions in the beverage industry. My name is Tony Lee. I am the Global Product Manager for the Evoca UV disinfection products, and UV disinfection is the topic for this webinar. In addition to covering the key elements of the UV process, we will be illustrating how it can be used as a technology in the beverage industry. We will also feature a couple of polls, which I hope you will participate in, and then we will finish with discussion points and questions. And for the discussion points and questions, I'll be joined by two of my colleagues, Dave McCarthy from the USA and Sueli Roel from the European team. This session will be recorded, so the materials are available for your review later. So, why disinfect? Waterborne microorganisms are responsible for adverse effects on flavour, colour, odour and shelf life of products, and not forgetting the potential health risks to consumers. It's therefore a fundamental objective for beverage manufacturers to eliminate microbes from process water and product water. And UV treatment is a widely used technology to combat microbes in water. It has a significant role to play in the control of microbes in the beverage industry, as well as many other industries as well. And without the use of chemicals, but also in conjunction with other disinfection technologies. So whilst UV is not a chemical treatment in itself, quite often it operates in combination with residual chemicals in some applications, or else periodic sanitization in others. The key issues for microbial contamination are the risks that these organisms present, not only as pathogens, but also spoilage organisms, so yeasts and molds. And also disinfection is important because of potential future environmental regulations on wastewater and water reuse, etc., that beverage manufacturers may need to contend with in the future. So disinfect solutions for the beverage industry, and this particular presentation is on UV. So Evoca themselves, we provide a number of disinfection technologies: UV, OSEC, ozone analyzers, gas feed and chlorine dioxide. But for this webinar, we are concentrating primarily on UV disinfection. The other technologies will be covered in future presentations as well. So to get us all going, I'd like to conduct our first poll, and it will be really great if you could all respond as best you're able. So let's try with the technology to get the poll running. So you can see the first question, it's to identify which areas of UV in beverage production you've experienced in yourself in the past. This is not select the best alternative. You can select any number of those if you've actually experienced of those. Okay, so the poll's open. We'll give you about 15 to 20 seconds if people want to actually complete the poll. Okay, some responses coming in now. I'll give you just a few more seconds and I'll close the poll. Okay, so I'll close the poll. I'll just share the results with you all. So as you can see, processed water and incoming raw water seem to be the most common usages people have seen for UV in the beverage industry. Quite surprising actually that the number I've seen on dechlorination, 24%, that's quite a high number. Not so much on utility water, and obviously we can see a certain element now starting to creep in for reuse and water recovery. No, thanks very much for that poll on the input as well. Okay, so back onto the presentations. So what is UV and what does it do? So UV is light at wavelengths short and visible light, so less than 400 nanometers. And in particular UVC from 200 to 280 nanometers, and to an extent UVB at around 280 to 315 nanometers have disinfecting properties. UV light passes through the cell wall of microbes and is then absorbed by the DNA of the microbes themselves. So the damage caused by the absorption of UV light prevents cell replication and inactivates the microorganism. Also for chemistry, sorry, apologies for that. For chemistry and chemical processes such as dechlorination, deozonation, etc., UV will break bonds within the target chemicals, breaking the chemicals down to constituent molecules. In general, as per the laws of photochemistry, the reduction in organisms or chemicals is dependent on the quantity of photons absorbed by the organisms or chemicals themselves, often expressed as the UV dose, but more correctly the fluence, which is a function of both the UV intensity and the time of exposure, which of course is the inverse of the flow. Exposure time can be very short, it can be less than 1 second, which is the time to pass through the water jacket. So it's a very fast-acting disinfectant, and in general, destruction of chemical contamination is one of two orders of magnitude above that required for disinfection, so therefore much higher doses, and that's really quite an important principle when we start to look at chemical reductions. Disinfection, relatively straightforward. We're causing sublethal breakdown of the DNA. For chemical destruction, we actually have to basically completely oxidize the chemical bonds themselves. So it is important to understand the system sized for disinfection will have relatively marginal impact upon a chemical reduction, and they do therefore need to be sized separately and can often be quite different and distinct products. So what is a UV treatment system? Some of you are familiar with UV or recognize these, but UV treatment systems comprise two basic elements. Firstly, the UV reactor or UV chamber, through which the water to be treated passes. This is installed in the pipework and is typically of a size similar to the process treatment pipework, particularly for disinfection applications. So, for example, a unit on a 4-inch piping line, for example, would connect to a unit typically with a 4-inch connector. So they are generally sized to the pipe, and that is really a result of the dose calculation, generally speaking, the dose you're looking for in these most applications. So the UV chamber itself, it houses one or more UV light sources, which are isolated from the water in a highly refined quartz sleeve. In addition, the UV reactors will include various elements of instrumentation, such as UV intensity monitors, so you can read actually the physical light output of the UV lamps, and temperature sensors. Some systems will also include automatic wiper systems, which is particularly used for those on raw water sources, where the contaminant loading might be quite high, and would be used, for example, in wastewater and wastewater recovery systems, would invariably use some form of automatic cleaning system to reduce maintenance intervals. Obviously, one of the key parameters for sizing a UV reactor, we talked about the dose before, is the flow itself. Generally speaking, UV reactors themselves would not incorporate any kind of flow measurement, but can accept easily signals from existing flow measurement devices within the factory or somewhere else within the installation. Photo on the left shows you two basic types of water jackets. So you've got the furthest left unit is an inline unit, and the unit on the right there is an axial unit. So inline systems are generally medium pressure polychromatic because you need the high power lamps to actually provide the overall length of the pipe, because your system installed and your pipe lengths are based upon, your lamp lengths are based upon your pipe diameter, so relatively short lamps. And then your axial systems are generally low pressure systems. Medium pressure systems generally emit polychromatic light, so emitting at multiple wavelengths between 200 and 315, which can provide better treatment for certain organisms such as adenovirus. They are higher power and generally occupy less space. So typically you would see medium pressure systems in space constrained installations. Axial systems are generally low pressure. Low pressure lamps are lower power and require much more space, but generally are more electrically efficient. And again, in both these cases, when we talk about pressure, we're not referring to water pressure. We're actually talking about the internal gas pressure of the UV lamp. So that's an important distinction. In terms of the terminology for lamps of pressure, that is really should be seen just as a type of lamp. So again, in general, the selection of the UV will depend on key parameters for the installation. Are we space restricted? Do we need particular treatment applications, such as for chemicals or for adenovirus or certain organisms, or do we need power efficiency? So again, the selection of the unit is very much dependent on particular installation conditions. The second element you see in the center is the control system. So this includes all the power supply systems for the UV lamps. It's connected to the instrumentation on the reactor. Visual display typically provides information on operational status, such as lamp hours, dose and current, and includes instrumentation readouts, such as the UV intensity would be displayed on the control system as well. And again, UV alarm statuses. Finally, in more advanced systems, you can see on the right, the UV can be integrated via Modbus or other networks into the factory management system, providing data, accepting key parameters from other devices, such as accepting a flow meter signal. All that can be done on a network now, such as Modbus or Profibus or an Ethernet connection. So these systems will often feature data logging as well. You can see on the right, there's an example of how on a remote web access, you can actually see the process parameters for a particular UV unit remotely. And this is really useful as factories become more integrated. So for example, the UV intensity readout on a UV reactor is heavily dependent upon the organic loading in the water. So trending the UV output and UVI signals can give you valuable insights, for example, on how filters may be performing. So if the filter efficiency is dropping and organic loads within the system are increasing, then you'll see that in the UVI sensor. So the review of UV data can help optimize other factory treatment stages as part of an integrated facility. And this is the sort of thing we see becoming increasingly relevant in the future. More and more processes are going to become more efficient by harvesting big data. So again, ensure that when you're looking to select any kind of process device, that interconnectability is built into those things so they can actually talk to other devices within the factory. So UV dosing, millijoules per centimeter squared. So it's important to ensure the UV unit is sized to provide the correct dose for the application. So few, if any, microbes are resistant to UV disinfection, given sufficient dose. Some need more, some need less, but they're all sensitive to a certain degree to UV. These sensitivities vary. If you're curious or need information on particular organisms, the International Ultraviolet Association maintains a really good database of organisms and the doses required for reduction. And that's kind of a freely available resource if you go on the IUVA website. From the sensitivities of the microorganisms you're typically looking to disinfect, typical dose specifications are utilized across the industry. So in most cases, we're going to see a dose of 30 or 40, which is more the norm. But in certain circumstances, doses will be higher. So for more difficult organisms, such as adenovirus, as we talked about before, which would typically be a dose of 120 to 186, depending on whether it's a medium pressure system or a low pressure system. And also chemicals. So for example, dechlorination. These have much higher doses. You might see doses of anything between 700 and 1,000 for a dechlorination application. Deozonation typically would be around 100 or just over 100 dose as well. So again, chemical treatments, breakdown of chemicals, generally requiring much more power and dose. Occasionally you may see the term fluence, and that is actually the correct term for dose. So UV dose is more the industry norm. We all understand the term dose. It's intensity times time, very similar to the CT on the chemicals, but technically the correct term is fluence, which you may see from time to time. And again, when you're looking at UV dosing, make sure you understand the units. So sometimes you'll see units expressed in joules per meter squared, which is around 10 times the numbers that you would see on millijoules per centimeter squared. So a dose of 30 millijoules per centimeter squared is 300 joules per meter squared. So make sure that you're always specifying and understand the units the system is being specified for. So where might we see UV located in a typical bottling plant? First, it's in the raw water of the factory inlet. This would very much especially be the case if the raw water source is a private source, such as a borehole, maybe not mains water, but even from municipal supplies, an additional disinfection step quite often would be taken, especially if the water source is variable in quality and especially if it is demonstrated to have previous issues. And this clearly would apply to areas more remote from high quality water sources, where typically you're taking from surface water sites, maybe in parts of the world where the facility and infrastructure for water treatment are weaker. UV will also be used post-filter or post-dechlorination, especially as these filtration steps can provide a breeding ground for microorganisms in themselves, even if regular sanitization takes place. So of course, using UV for dechlorination would not require a post-UV disinfection step after the dechlorination, because the UV for dechlorination would provide more than adequate dose for disinfection. And so once in the factory itself, where chemicals are used only periodically, the routine sanitization are not included in the ongoing disinfection process. So the absence of chemicals can eventually result in microbial growth. So a few years ago, I was involved with a particular plant. Although they had a UV post-filter, they hadn't carried out any sanitization for a number of years. And then eventually the problem of microbial growth downstream in the factory, it was many years before it became a problem. But again, regular clean in place systems are required if you're going to require no residual disinfectant. So UV at each step of the process can ensure that the water is microbe free, and this would apply to the bottling plant, washing and rinsing processes, and also ingredient water. And again, where CIP is used, any water used to flush the lines post CIP, that can be treated with UV to prevent reintroducing contamination. And where water is discharged from these processes and have a high microbial loading, we can use UV for wastewater recovery processes, such as washing down. And increasingly, we see that regulations governing reuse of water in water-stressed areas include processes for evaluating UV. So, for example, California Title 22. So we do see in the future water reuse and water recovery being a critical parameter for all manufacturers. Quick advantages, selection of the advantages of UV. It's effective, it's efficient against a wide range of organisms, and particularly against strains that have more resistance to chemicals or have developed increasing resistance to chemicals. It's fast acting, contact time is around a second for some systems. And there are no significant byproducts at disinfection doses. And again, no storage issues except storing the UV lamps themselves. Equipment is easy to use and easy and safe to maintain. Doesn't need highly specialized operators. Maintenance is infrequent, not daily or even weekly. It's a number of months between maintenance typically, and in some cases, only annual maintenance or calibration is required. And finally, disinfecting waste streams or treating water to be recovered and also generally making more efficient use of water resources is key to driving sustainability in the future. And again, replacing certain processes that currently use pasteurization, for example, will see power savings by utilizing UV. And an example of that would be the pasteurized milk ordinance in the USA. Just a quick couple of case studies. Again, names have been withheld to protect the innocent. So the first one we're talking about here is a case study from California, the USA. And in this case, the producer was challenged with organisms that were resistant to the existing pasteurization process. And the presence of these organisms in the final product could affect both product quality and even affect product recalls. So by adding a UV unit in the process, the problem of heat-resistant organisms was eliminated. And the juice processor in this case could protect the brand and provide increased shelf life, which are key drivers for products in a market driven increasingly by a need to reduce preservatives in products, for example. And then another case study, which again is about disinfection of incoming municipal water. This is an example from South Africa. So the client needed to protect the incoming factory raw water, as the quality of the incoming water could not be guaranteed. There were concerns about organisms that may be more resistant to other treatment processes. And due to the risk potentially of adenovirus again, the client required a higher dose UV system. In this case, specified a dose of 120 millijoules per centimeter squared. And this was equipment providing both filtered and unfiltered water, and a flow rate of 250 meter-cubed/hour. That's quite a high flow rate into a factory, and that combined with the 120 dose requirement was a reasonably large size system, and therefore needed to be a high specification unit. And in this particular case, the unit was selected as it was validated for both the process and flow. So I'd like to, at this stage, conduct another poll, which is really an ongoing from the previous poll, and really to determine how we see the market in the future, or how you see the market in the future. So really, it's, again, can you please identify the areas in the market in the future where you think there will be a change in terms of the strategy? Where do you expect to see potentially UV in the future? So I'll give you a few seconds for that poll as well. Okay, I'll give you a few more seconds. All right, and I'll close that. So if I'll just share the poll. So what we can see there, quite interesting, 73% reuse for water recovery. So obviously a number of you on this call actually see water reuse is going to be critical in the future, and that's, I think, something that I think we all feel is going to be the situation as well. So again, these poll results will be available as part of the presentation. Okay, so again, why Evoqua UV systems for your beverage applications? Partnership, results, production uptime and yield, compliance, and low operating costs. And that's not just applying to the UV systems, of course, that's really about all Evoqua's products. So, like to go on now to the discussion points. And for that, I'm going to invite a couple of colleagues. That's Dave McCarthy, who's our industrial sales manager from North America, a lot of experience in the North American market, and Sueli Roel, who's our industrial sales manager for Europe. So the first discussion point is, what impact will new regulations have on the industry, and any impact on sustainability? So I'll pass this question to Dave first.
Thank you, Tony, and welcome everyone. The first question about the impact of existing and upcoming regulations, that's a fairly broad topic. As Tony mentioned, a lot of it is has to do with compliance. So for example, in the US, we have what's called the Food Safety Modernization Act that was introduced in January of 2011. And it's because of the issues of contamination within products. And this includes food products, it includes juices, bottled water, beverages, beer, whatever you have is covered by this regulation. Because yearly, we have about 48 million people in the US that are get sick. That's 1 in 6 that get sick from foodborne illness. 120,000 are hospitalized, and 3,000 die each year. So because of the FDA has instituted these, and there are compliance regulations that are required within a plant. So when we talk about regulations in general, most of those foodborne illnesses are microbial. So that's one of the big focuses of all these beverage plants that you're involved with. Particular focus is on bottled water and flavored bottled water and mostly juices. So within your plant, you probably have a quality control manager that has to be compliant with current good manufacturing practices. We call them CGMP. And as Tony mentioned on that one slide, that showed all the different points of disinfection within a water treatment process. Those are the areas of critical control points. And so that's why we look at UV to be able to meet those regulations and provide, along with disinfection and sanitization, CIP, to provide safe and efficient products. And now I will pass it over to Sueli for her comments.
Yes, thank you very much, David. Thank you, Tony, for this brilliant presentation. All on the point. As you said, water scarcity is increasing, and this will be worldwide driving the implementation of water reuse. And this is one of the points what we saw also in the pool. And the implementation of water reuse sooner than later are implied by technologies which also reduce the impact on energy consumption, on chemical discharge, and regulations on wastewater treatment. And these are points where I see a big play for the UV systems because they are called as such green technology and will contribute for the sustainable development of the process in the beverage industry, either on water reuse from CIP to cooling towers and other utilities, for example, or for water reuse, for irrigation, which is also a big point. And all these coupled with the HACCP protocols, which grant the safety for the process in the entire plant. But I think you have also mentioned the PMO and other regulations, and you will see more and more. This is good practice. This is the way the beverage industry is developing. Tony, you have any more comments?
Well, it seems Tony may be having some issues with his microphone there.
I think so.
But I'll take up the second point, which also has to do with sustainability. But we talk about, how is UV providing production safety? And UV is considered environmentally friendly because it doesn't add chemicals to the water. So without using the chemicals, we minimize the use of chemicals, and that's chemicals are also associated with personnel safety. So that's one of the areas that we promote with UV, although every different type of disinfection technology that we offer also has a lot of safety issues for not only the products, but also the plant personnel.
Yes, and on the other side, the UV is being used for more than 50 years, also in municipalities, and is considered good practice. And it's as Tony mentioned, if the plant is well disinfected with the CIP, UV on the point of use or on the water recirculation is granting that immediately by the contact with the UV light, the microorganism is inactivated because the DNA is destructed. So with that, you can be sure that your product is safe, or the water being used in your product or in the process of production of your product is safe. I see Tony left, he's having technical issues. Perhaps we could open now for our Q&A, and you can people from the audience can drop us questions by the chat, and we would be glad to open our Q&A session. How do you choose the best application before the ultrafiltration? Okay, it depends to size system and to choose it. It depends on the parameters. So the best way to define is to have your water quality specifications. The most important are flow, UVT, which is the transparency of the water that can be shown there are instruments that can measure it for you. We work with some established values, but it's important because the UV dose is defined through the intensity and transparency and flow of the water. Perhaps this is one for you. Is there any risk of breaking glass of the UV lamp entering the water, Dave?
Yeah, so UV lamps are housed by a quartz sleeve and in the water in the UV reactor. There is some risk of breakage, particularly with water hammer. In 30 years in the business, I've only seen it happen once in operation, and that was it. A lot of times it happens during maintenance where somebody's trying to remove a lamp and quartz sleeve and they break it and it gets into the piping. So yes, there is a risk, and we have to mitigate that. If there are if something, if one of the quartz sleeves cracks, for example, it will trigger a ground fault and shut the system down and go into an alarm. And then some operations will actually have a downstream valve that closes until the system's cleaned.
Yeah, I've seen also, but there are also some safety features in some equipment that can save when you are exchanging the lamp, that you break the quartz spot. So this technology is so modernized by the actuality that it is a point to mitigate. We have another one based on why UV treatment can be used in combination with ozone. This is a very good one. You know, we are speaking here about two non-chemical applications where you have the ozone as an effective oxidation media, and if you want to be sure that you don't have any ozone residue on your water, you can use the UV to destruct this ozone or cancel this ozone as Tony described. And there are other points of application. Perhaps you pick on this, Dave, also?
Yeah, so UV and ozone are synergistic in most situations. UV is, the disinfection happens instantaneously. With ozone, there's some type of residual ozone in the process. It also has the advantage of breaking down certain organic compounds. And as Sueli mentioned, for sanitation, it's an ideal situation to have ozone that you inject into the piping and the tanks. And then when you're done with the sanitation and recirculation, you turn on the UV at a UV dose of 100 to 120, and you break down the ozone and you're off. So they both have their advantages, but a lot of times they're just synergistic in a process.
Oh, we have Tony back. Great, Tony. You can pick the next one.
Okay, I apologize for that. So we've just done the ozone one. Yeah, I had a speaker problem. So so I can open up the questions. Wow, we have a lot of questions.
Yes, we don't pick all of them.
Okay, so I have a system where I'm not sure how far we've got down to these, so we've just done the ozone one, I guess. We've done the breaking glass. Can we use UV for high viscosity liquids, for example, defoamer. Could you take that one, Dave?
Yeah, so we have there are certain when you have low transmittance fluids, you have to have systems design, reactors designs with lamps closer together and in smaller diameter chambers. So we take that into consideration when we size a system for these low transmittance fluids like sugar syrups or whatever. And a lot of times these are also recirculated, so you get number of passes through the UV system, and we take the piping processing into account as well.
And then I have a system where the effluent from RVF are treated by nanofiltration, however, are issued with microbiology. Any comments on that one, Dave?
So if I understand the question correctly, there's ultrafiltration and there's post-contamination.
Yeah.
So ultrafilters are good. They don't take out everything. And often the polishing step is the ultrafilter or even membranes or whatever is followed by UV. And it takes out any of the microorganisms that might survive that process. It's also important to make sure that the piping downstream is sanitized. A lot of times those types of situations is biofilm growth on the piping. So those have to be taken into account when you sanitize your system.
So we've had quite a few questions from Ehab Ali Mohammed, which are all very interesting, but they're also they're actually quite specific to product sizing and so on. So what I suggest for those questions is we'll actually take those offline. We'll get a response together for you, and we'll go through those in more detail. So that's really about a particular flow and sizing system. So we will respond separately by email on those questions.
Tony, I had a question on what is the difference between a validated and non-validated system?
Okay, so a validated system, validation is used in a couple of different ways in the UV industry. In certain cases, historically, validation has been used about certificates for this material and certificates for other materials and instrumentation. In the UV industry these days, validation generally refers to a third-party bioassay test of the equipment, not with the organisms that we're treating, but with surrogates. So we understand the biological process much better, so we understand exactly how to rate the UV unit. So that is what we talk about, what we really mean when we talk about validation in the UV industry.
This is related to RED dose, is the continuous question.
Correct.
From this.
Yeah, so an RED dose, reduction equivalent dose, is a dose measured by the reduction in an equivalent organism, such as a surrogate.
Okay. Thank you.
So another question is, if the flow rate of the process is dropping significantly, to what extent the dose rate of the UV must be adjusted, turned down? Can we turn the systems down, Swelly, if you want to run with that?
Yes, the flow is, the systems are designed to a dose, and the dose is an impact from the UVT and the flow, as you said, inverted proportional. So if the system is well designed, it will take on variations of the flow rate, because either the flow rate is transmitted by a signal from an existing device in the factory, or the system will pick on the intensity that is reading on the instruments.
Okay, thanks for that. And another question for you, Dave. If we have Pseudomonas or E. coli on the raw water, can we install a UV unit to get rid of Pseudomonas and E. coli?
Yes, absolutely. As Tony put up on one of the slides about UV dosing, Pseudomonas, very common, ubiquitous microorganism, often found in water supplies. UV is very effective in activating Pseudomonas and most of those types of organisms. So yes, that's a great application of putting UV in. It's somewhere around 30 to 40 millijoule dose would be needed.
Okay, We have quite a few other questions that's come in, actually an incredibly large and long list of
Yeah.
questions. And we're actually running out of time. This is scheduled for 40 to 45 minutes on a presentation. So what we will do is we'll take all those questions. We'll make sure we get a response to you for each of those questions, particularly those that are dealing with a particular specifics for an application. And if you have any other questions as well, please email us and we'll confirm either Dave or Sueli, and we'll get back to you on any specific applications or requirements. What I'd like to do is just spend the last minute or so quickly going through, it's a little bit down the line, but I just wanted to just mention the European Parliament regulations now on water reuse. And I think that's a really interesting subject because the European Union is now targeting water reuse specifically with regulation. And at the moment, it doesn't directly affect the beverage industry. It's mostly about wastewater and water recovery for agriculture. What's really interesting to me, is that they specifically in the preamble mention industrial users of water, of which, of course, the beverage industry is a big industrial user of water. So the European Union expects industrial users of water more and more to be challenged about how they reuse water. And the other thing to remember, I think, which is also interesting, is, of course, whilst people see agriculture and irrigation of agriculture as a food processing issue and not as a beverage issue, of course, many of our ingredients are crops, so sugar beet, for example, in many processes. So increasingly, when we look at the environmental impact of a beverage producer in terms of sustainability, we have to look at start to finish of the process, and the start of the process can be agricultural use. So it's quite useful, I think, to look at some of the major manufacturers such as Coca-Cola, even on their website, really starting to address sustainability from the whole of the cycle, from when you start growing whatever crops that form your ingredients, right down to your final bottling and deliverable. How sustainable is this? Because obviously, in many water-stressed areas, using precious water resources in beverage plants will be seen in the future as sustainable issue. So I'd just like to close our presentation on that thought, that the beverage industry, start to finish now, needs to start to demonstrate its environmental credentials by looking at the whole process of producing bottled soft drinks, water, or whatever it is. Okay. Any other final thoughts from yourself, Dave and Sueli?
No, I fully agree with you. And this is as our poll said, water reuse is the way, and water scarcity is the drive.
Yeah, I agree with you too, Sueli and Tony. I should mention that Evoqua has a corporate group that's just focused on sustainability within our organization. So it's not just in the food and beverage industry, but all companies now are looking at as, a sustainable environment going forward. And you can find that on our website, just to mention.
Okay. So finally, just to close out, we'll go down to the last slide. Part 3 is ozone for effective disinfection and sanitization. It could be a different team. Hope you're all available to join us again on that particular presentation as well. So with that, big thank you to everybody that attended. Thanks very much for answering the polls. And again, we'll make this available for you in the future. Thanks very much.
Thank you.
Thank you, everybody.
Everybody.